In this video, we study a reaction that proceeds through autocatalysis or self-catalysis, which indicates that one of the products acts as a catalyst to the reaction. We mix the indicated amounts of reagents, The limiting reagent is potassium permanganate, so at the end its purple color will be fully decolorized. Oxalic acid reacts with permanganate ions in acidic conditions in an oxidation-reduction reaction to carbon dioxide and manganese sulfate. The bivalent manganese produced speeds the reaction itself, a process called autocatalysis. Bivalent manganese formed reacts with permanganate to produce manganese 3, which in turn, and as a reaction intermediate, reacts rapidly with oxalic acid to yield carbon dioxide and to regenerate the manganese 2. If you do the maths, for each 4 bivalent manganese ions consumed in the first reaction, 5 are produced in the second. At the same time, color change is also observed as permanganate is reduced in a stepwise manner to manganate and to manganese dioxide. See that insoluble dark brown solid? That's manganese dioxide. If we mix it up, we set off the reaction again, and manganese dioxide is finally consumed and colorless bivalent manganese prevails. As you probably noticed just a minute ago, the reaction kicked off slowly with no apparent carbon dioxide production, but then carbon dioxide bubbles start to appear and became more and more evident. To quantitate the kinetics of this reaction, we set an inverted graded cylinder in water, a spherical flask with a magnetic stirrer, and a stopper, and a tubing to collect the carbon dioxide produced and measure its volume by time. We add the same amounts of potassium permanganate, sulfuric acid, and oxalic acid as previously, start the stirrer, place the stopper, and start the stopwatch. Initially, reaction is very slow, and actually nothing seems to happen. At that point, I should have speeded up the video, but then the picture would have been trembled a lot. Production of small amounts of manganese 2 catalyst speeds up reaction, and CO2 bubbles appear in the cylinder. With a progressively increasing rate. As time goes by, the rate of bubble production decreases again. For a better understanding, CO2 volume over time is plotted. This experiment is a very useful educational tool, since students themselves can observe the experiment in live and review the video later and plot a graph of carbon dioxide volume as a function of time. Revealing the characteristic S-shaped curve with low reaction rate at the beginning in the absence of catalyst, high rate on the middle, and low rate again due to exhaustion of reagents. This is drastically different to the curve of a classical catalytic reaction, where a curve in the form of a hyperbola is plotted.